This video is about quadratic applications. We're going to be using quadratic word problems to be able to solve problems. What we really have to do when we're reading a word problem is figure out what is the question asking us for, and if we can, to draw a picture. So the first problem that we see is a relief package is released from a helicopter at 1,600 feet. The height of the package can be modeled by the equation h equals -16 t squared plus 1,600, where h is the height of the package in feet and t is the time in seconds. The pilot wants to know how long it will take for the package to hit the ground. So we want to be able to draw a picture of this. We have a helicopter flying in the air and it has a package, so we know that it's in the air. If we're thinking about for graphing this equation, this would be a parabola and it would be opening down, so it would look similar to just an upside down parabola. But the thing is that it's starting up at 1,600. Your y-intercept is at 0, 1,600 because that's your constant. It's also going to be inside that first quadrant because we cannot go back in time. It says that h is your height and t is in time. We cannot go backwards in time, so we cannot have our x values be negative. You can have your y value be negative if you're dealing with digging in the ground or underneath sea level. But for this case, since we're talking about hitting the ground, our ground is going to be our x-axis. So what we want to do is we have a picture. I'm going to draw only specifically the first quadrant. The x-axis is actually our time, so I'm going to put t, and our y-axis is our height, so I'll put h. Now what's really happening is that the package is starting up at 1,600. It's in the air, so it has not been dropped yet, so it's going to start around here. This is just a sketch of the graph. It's starting here, and we know that it is a parabola, so it should end up coming down. And it will not go further than the ground, so our package will end up right here. I'm just going to draw a little package. So the question comes from this equation, h equals -16 t squared plus 1,600. That's our actual function. So the -16 t squared tells us that it is coming down, and then plus 1,600 tells us that that 1,600 is our y-intercept. So this right here is actually at 1,600 feet. The question says how long? So it's talking about time. How long is time? It's not asking about height. How long it will take for the package to hit the ground. So it will take for the package to hit the ground. Now when it wants to hit the ground, what is that really asking for? If it's hitting the ground, your height is actually at 0. Your height is equal to 0. So what is that in quadratics? You have multiple points that we can talk about. We have our y-intercept, which is where your graph is actually starting from. You have your vertex, which is the highest or lowest point. You also have your x-intercepts. Your x-intercepts is when the y value is 0. And in this case, our height is our y. So really, we're looking for the time when h equals 0. So in this case, that's our x-intercept. These are the x-intercept, which another word for that is root, or a 0, or just a solution. So write the equation that you are trying to solve. So we're going back to this equation. We want to know how long. That's really asking for our time. Our time is our question. That means that we don't have the time. So if we go back to our equation, we don't have the t. We don't have t, but we do have h. In this case, our height will be 0. So 0 equals, and then we have that original equation again, -16 t squared plus 1,600. So we're really just finding the x-intercept. We want to solve this. You can solve this using your calculator. You can solve this by trying to factor. You can solve this by using quadratic formula or trying to complete the square or using square roots. I'm going to use my calculator for this just so that I can show you how to, again, do this in the calculator. So what I do is I put my original equation, my y1 is my negative 16, and this time, since we're using t, that's really still going to be our x plus 1600, but then on our y2, we're going to put 0 because we want to find where they intersect. So we'll do our second trace, and we want to find where they intersect, 5. So y equals, my y1 is negative 16, I'm going to use the letter x because I can't use t, squared, plus 1600, and then my y2 is going to be 0. So I'm going to press graph, or actually I'm going to press zoom 6 so I can go back to a nice regular screen. This is where it's starting from, and then it comes out over here, so I can't really see my graph. I'm going to press zoom. I'm actually going to go down to zoom 0, which is zoom fit, so that it can actually fit the graph. This was the y-intercept. This is at 1600 feet, and what happens, this graph is not being needed because this is when it's negative time. So I want to show that this is a 1600. It's coming down. It's going to hit the ground right here. I don't need to see anything underneath that because it's not going to go underneath the ground. So I want to find the intersection of that. So second trace, we want 5. I want to go down to here, so I'm going to press right. Now the reason we don't want to know this one is because that's a negative time. We know that our time cannot be negative. We're going to press enter, enter, enter. And our intersection is at x equals 10, and our y is 0. So x equals 10 is our answer. Now what does that mean? The question was asking how long it will take for the package to hit the ground. So we write it out. Since this was a word problem, we write our answer in words. It will take 10 seconds, because it says time in seconds, for the package to hit the ground. And we can make sure that this makes sense because it's something falling, and it's not too high up in the air. It's 1,600 feet. A mile is 5,280 feet, so it's not even a mile in the air yet. So it should not take that long for it to hit the ground. So 10 seconds is a good time. So again, we figure out what is the question asking for. So how long, that's what you have to figure out what variable you need. And then you have to know what value you have to hit the ground. We have it hitting the ground. That's our height of 0. So if we have two variables, one of them will know, the other one we won't. So it's saying how long. That means we need to know our time. We don't have it. We do not have t. That means that we have the h. You just have to figure out what the h is. On the second problem, the height of a flare fired from the deck of a ship in distress can be modeled by the equation h equals negative 16t squared plus 104t plus 56, where h is the height of the flare above water and t is the time in seconds. Find the time it takes the flare to hit the water. So again, we want to focus on that equation. The question is asking, find the time. So that means that we don't have the time. That means we do not have t. So our time is our question. Time that it takes the flare to hit the water. So again, we have our equation. T is the letter we're looking for, therefore we have to have h. So if it's hitting the water, again, if it's hitting the water, then your height is actually 0 because it is no longer in the air. So again, we want to try and draw a picture. And again, this is going to be in the first quadrant because we cannot have negative time. We're going to focus on the first quadrant. So our time is our x value, and our h is our y value. Now, if you think about a flare will be shot up into the air and then it will come back down. Now, is it shot from the water? It's saying that it's shot from the deck of a ship in distress. If you look at your equation, your y-intercept is, and when you're in standard form, it's your c value. So it's actually starting at 56 feet. So we're talking about 56 feet in the air, or 56, it doesn't say what unit it is for the height. So it's 56 on the y-axis. So we can put somewhere right here. Now, if this is the deck of the ship, that means the ship is in the water, but this is the deck of the ship. So when a flare is fired, you don't fire it straight out. You don't fire it down into the water. You want to fire it up into the air so other people can see it. So it fires up, and then it comes back down. So we're just going to draw a slight sketch of this. It's going to draw up, and it's going to come back down. And then it'll hit the water. So this value, again, is 56. Now I'm going to use feet for my measurement. And the question is asking, when will it hit the water? So this is where we want. This is, again, called the x-intercept. So what are you looking for? We're looking for time, so t, when h equals 0. Since we know the h is 0, we can plug it back into our equation and put that 0 right there. So 0 equals, and then we just write that equation out again. Negative 16t squared plus 104t plus 56. We want to answer the question, so we want to do this. We can do, again, using the quadratic formula or completing the square or try and factor it, but I want to try and use it in my calculator since it should cross the x-axis. So my y1, I'm going to put the original equation, negative 16t squared plus 104t plus 56, and then in y2, which is what I want it to hit 0. Again, we put whatever is on one side in our y1 and the other part on your y2. And we want to find, since where it intersects, second trace 5. So if we go into the calculator, I'm going to clear out my original one from the first one. So I have negative 16, I'm going to use x squared plus 104x plus 56. And then my second equation, I need to make sure it's still 0. Now if I go back to zoom 6, so I can see a standard window, and see what happens. We can see that it's going up and then it's coming back down. Now we know the y-intercept will be way up there on the 0.56, but what we really need to know is this value. So I can actually stay where it is right now, even though I don't see the whole parabola. We really want to focus on this part. We do not need to find this value because that's a negative time. That also means that it has not been shot yet. This value right here is when it has not been shot. As soon as it's been shot, then it starts moving. It's going to be moving towards the right. So when we do our second trace 5, notice I'm at 0.56 because that's my y-intercept. I know I need to keep it moving to the right so that the flare will hit the water. So I'm going to move it to the right, and my numbers are going to change. So I want it to go, it has to come up. So my y values are still going up. And then I want it to start coming back down. So it's still going up. Now the y values are starting to come back down. So now the flare is coming back down. And I want that flare to come towards the 0. So as you can see, if I go right too much, it goes way down to the negative. So I just want to get as close as possible to this. I am as close as possible to it, so I can press enter 3 times. Enter, enter, enter. The intersection is at 7, 0, so that means our x value is 7. X equals 7. So again, in words, we want to say, find the time it takes the flare to hit the water. The flare hits the water after 7 seconds. And it does tell us that our time is in seconds, so we do know the unit of measure for that. So the flare hits the water after 7 seconds. And a flare should not stay in the air for that long, so that would make sense that 7 seconds is not that long. If we go to the next problem, I'm going to go in here. Next problem says the height of a rocket launched upward from a 160-foot cliff is modeled by h equals negative 16 t squared plus 48t plus 160, where h is the height in feet and t is the time in seconds. So we have our equation. And you also notice that it says plus 160 at the end. That's your y-intercept because the rocket is launched from a 160-foot cliff. Question is, what is the maximum height the rocket reaches? So maximum height, so that's what we want to find, is the maximum. We want the maximum height. Now a maximum, another word for that is vertex. So we really want to find the vertex. But the question is, a vertex has two coordinates, has a coordinate, has an x and a y. So which value do we want? Because it's asking for height, that is the y value because it's talking about the height. This is the y value of our vertex. So maximum means we're dealing with the vertex, but the height means we want the y value. So again, if we draw a picture of this, it's going to be launched from a 160-foot cliff. So again, we're going to be dealing with the first quadrant. 160-foot cliff, so around here. This is time, this is height. Going to be launched, and then it will come back down and crash to the ground. But what is the question asking again? It's asking for the maximum height. So we really want to know this value. That's what we want. We want the vertex. So what are we looking for? The y value of our vertex. Because vertex is another word for maximum or minimum. So how do we solve this? You can write the equation to solve this, or you can do it in your calculator. So to write the equation that you are trying to solve, you actually have to find the vertex, and you can do this algebraically. You can do your x equals negative b over 2a, and once you find that, you can then plug that's your axis of symmetry, plug an equation to find y value. So plug in AOS to find y value. So we can do this algebraically, or we can use our calculator for this, and I'm actually going to show you in the calculator. So in our calculator, our y1 will equal to our negative 16 t squared plus 48t plus 160. Now our y2, we're actually just going to leave it blank because we're not trying to find where it intersects anything. We just want to find the vertex. So we're going to leave y2 blank. We still do our second trace, but since we're finding the maximum, we find which one represents maximum, and this should be 4, because the 4 should represent your maximum. So I'm going to go to my calculator, clear what I originally had. I'm going to take my y2 out. I'm going to have negative 16x squared plus 48x plus 160. Now I can go back to zoom 6 and I'll do a 10 by 10, but I know since I want 160 up here, I know that a 10 by 10 scale won't really work, and I know it's going to be, my vertex will definitely be above 160. So if I actually go to zoom fit, it should graph it to be where you can see the parabola, so we can at least start with that. So we'll go to zoom 0. Now this parabola, you can see it going up and then coming back down, so we do have a vertex. Now this scale is not counting by 1, so be aware of that. I want to find that vertex. So go to second trace, and we want 4 because we're dealing with the maximum. 4. Now it does say left bound. That's my vertex around there. So as long as I'm on the left of my vertex, I can press enter. So enter once, then the word say right bound. So I want to press right, and I want to get to the right side of my vertex. I'll press enter once I'm on the right side of my vertex, and then I'm going to press enter on guess. So I still press enter 3 times, I just have to make sure I move it. Now the maximum is at 1.5 and then 196. So 1 and 5 tenths. Our maximum is at 1 and 5 tenths, 196. That was our actual vertex. Now which part of it is what we need is the y value. So we go back to our words. What is the maximum height of the rocket? So we can say the maximum height the rocket reaches is 196 feet. Now, if the question asks, when does it reach its maximum height? When is our time. So it takes 1.5 seconds for the rocket to reach its maximum height, and then it falls back down to the earth. So it really is just asking, what are you looking for? Finding the question and understanding what the question is asking is the most crucial part. This next one, Robert threw a rock off a bridge into the river. The distance from the rock to the river is modeled by the equation h equals negative 16t squared minus 16t plus 60, where h is the height in feet and t is the time in seconds. Find how long it took the rock to hit the surface of the water. So we have the equation. It is in standard form. So at that plus 60, that's your y-intercept, that's actually where Robert was located. So that means the bridge is actually 60 feet above the river. Then it's asking, find how long. So that's what we're looking for, how long. How long. How long? Long means time. How long? Time is our question. It took the rock to hit the surface of the water. So when it's talking about the surface of the water, we are looking for time. So that means that we're looking for t. We should have h. Surface of the water, again, means height is equal to 0. So if we draw a picture of this, we're in the first quadrant, because Robert's throwing the rock from the bridge up here at 60 feet. He's throwing it. When you throw something, again, you don't throw it down. He's throwing it up into the air and then coming back down. You throw something and it comes back down to the ground. This is our time, this is our height. So again, Robert is actually standing 60 feet up on the bridge because that y-intercept. The bridge is 60 feet up in the air. And we want to know when it hits the ground. So the question is asking, what are you looking for? We want the time, t, when h equals 0. And again, this is just right here, when does it hit the surface of the water? So that's our x-intercept. So we plug in our 0 is our height, so we can plug it into that equation. 0 equals, and then we have negative 16t squared minus 16t plus 60. And we can again use our calculator for this. Since we have an equation that we have a y1 and a y2 for, we want to find an intersection of these two values. y1 is that negative 16t squared minus 16t plus 60, and our y2 will again be that 0 since we want to find the intersection. We'll again do our second trace 5 because we want to find the intersection. So we go to our calculator. I'm going to go back to my y equals and clear out what I had earlier. I have negative 16x squared minus 16x plus 60, and then y2 I need to put 0. So I'm going to go to zoom, and because of the last one I had, it was zoomed really weird, so I'm going to press zoom 0 again so it'll fit this graph. And there's our parabola. You can see it goes up, and this is actually where we're looking at. This little section right there. It's really hard to see. I can actually zoom in on that, so I'll press zoom 2. And I actually want to zoom in on this area so you can see it a little bit better. So this is where Robert's standing, and he's throwing the rock, and it's going to hit the water right here. So we want to find the intersection. So I'll do second trace. I want 5. Then I want to go to where the rock is hitting the water. This is the rock hitting the water. So I press enter 3 times. Enter, enter, enter. So 1.5, 0. So our x value is 1.5. So again, we go back to the question, how long it took the rock to hit the surface of the water. So it took 1.5 seconds. It took the rock 1.5 seconds to hit the water. Again, we're throwing something, so it shouldn't, we're not superhuman, so we can't throw something that takes a minute for it to hit the ground, especially if we're only 60 feet in the air. So our answer, actually, if we think back to the problem, it makes sense with what Robert is doing. Robert's just throwing the rock. Number 5, during a game of golf, Kaylee hits her ball out of a sand trap. The height of the golf ball is modeled by the equation h equals -16t squared plus 20t minus 4, where h is the height in feet and t is the time in seconds, since the ball was hit. Find how long it takes Kaylee's golf ball to hit the ground. So we have our equation. What's different about this equation is that your y-intercept is actually at 0, -4. Now, why is that? If you know anything about golf, the sand trap is, if this is the green, if this is your where you're trying to hit it, sand traps are actually below here, and they have to hit it up, and then it has to keep coming back down to get into the hole. So a sand trap is actually below the ground because it's in a ditch almost. So if we draw our picture real quick, still in the first quadrant. This is still T and this is H. What's happening with Kaylee is that her ball is actually sitting down here at -4 feet. So when she hits it up, she'll actually hit the ground, not actually hit the ground, but hit it at ground level. And then it'll keep going up, and then it'll come back down, and it will stop on the ground itself. So what is the question? What are we looking for? How long, so find how long it takes Kaylee's golf ball to hit the ground. So it takes Kaylee's golf ball to hit the ground. So how long means we need to know our time. So if we need to know T, we don't have T, we should have H. Hit the ground. The ground is when your height should be at 0. Ground level is your 0. So hit the ground is height equals 0. So what are we looking for? We're looking for the time when H equals 0. Now the difference here is that the ball will actually get to the surface 2 times. This is what I was talking about just a second ago. Write a little note. The ball gets to the surface, hits the ground level 2 times. The first time is when it's coming out of the sand trap. When coming out of the sand trap. That's right here. After Kaylee's hit the ball, it gets out of the sand trap, and then it keeps going up into the air and it comes back down. So, and it also hits the ground when it's landing on the ground. So which one are we looking for? We want to know how long it takes Kaylee's golf ball to actually hit the ground. It's not actually going to hit the ground here because you're just getting it out of the sand trap. It's getting to ground level, but there's nothing stopping the ball from getting out of the sand trap. So this is just where it hits ground level, but doesn't actually hit the ground. So we want to keep going until it actually physically stops on the ground, because it'll keep this one going, because in golf, again, you're just getting it out of the sand trap. So we want this value right here. So our equation that we can still write, we do have our H is 0, so we can put 0 equals, and then we'll put the rest of the equation. negative 16 t squared plus 20t minus 4. We can again use our calculator. This is at a y1 is going to be our negative 16 t squared plus 20t minus 4. Our y2, we want to find the intersection, so we will put that equal to 0. Anytime we have the height as 0, we do put y2 equals 0. So we'll do our second trace 5. And we are going to get our 2 x-intercepts, but again, we're only going to use one of them for our answer. Let's go to my y equals, clear this out, negative 16x squared plus 20x minus 4, and I already have my y2 as 0. I'm going to press graph and see what happens. Now, it looks almost as if it's not actually crossing over. So what I'm going to go back to is do zoom 6 so we can see the parabola. So here's the parabola. I can actually zoom in on here too. So zoom, I'm going to zoom in too. Then I'm going to press enter over here. Here comes the parabola. So actually this is where the sand trap is. And she's hitting it up. It's finally getting out of the sand trap here and it's going up, 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 and it's going to hit the ground. Now, in real life, this aspect is not done right here, what I'm covering up, because it will not go underneath the ground again. So we want to find both of these. So second trace 5, I want to find this first one. So I'm roughly there, so enter, enter, enter. So our x is equal to 0.25 or 2500, so a quarter. So x is equal to 1/4. And then we'll do the second one. Second trace 5 again and go over to the right hand side. Get close to it. So enter, enter, enter. This is at x equals 1. X equals 1. So the reason why, again, why we have 2 is because it takes a quarter of a second for it to get out of the sand trap. So this is when it's coming out of the sand trap. Coming out. This is the one, x equals 1, is when it's actually landing. This is the one we want. So our answer is asking how long it takes Kaylee's golf ball to hit the ground. The golf ball will hit the ground 1 second after being hit. It takes a quarter of a second for it to get out of the sand trap, but then it's taking a second for it to, an entire second for it to get up to here. Now, probably the reason why that's happening is because she just wants to get it out of the sand trap and she's not trying to make it into the hole yet. So she's just trying to get it up and out so that she can make another shot. This last problem, the height of a rock thrown off a cliff can be modeled by the equation h equals negative 16 t squared minus 8t plus 120, where h is the height in feet and t is the time in seconds. How long does it take the rock to reach the ground? So we have a rock being thrown off a cliff. We don't have a person throwing it, but we know that it's being thrown. So we have our equation. So this is very similar to the other ones we've done. The question is asking how long does it take for the rock to reach the ground? Does it take for the rock to reach the ground? Again, the ground is when your h is equal to 0. We need to know our time. So when we draw a picture, we know that the rock is being thrown off a cliff. So it's going to be up in the air. So it's going to be thrown up, and then it's going to reach down. Now, it's actually starting at 120 feet up in the air because our y-intercept is 120. So it's 120 feet up in the air. The cliff is 120 feet up. So what is it that we're looking for? We need to know our time when h equals 0. So the equation we can use, we have our h, we can plug 0 in for that, equals, and we have our negative 16t squared minus 8t plus 120. So to answer the question, we're going to use our calculator. Our y1 will equal to that negative 16t squared minus 8t plus 120. And our y2 will equal to 0 because we want to know when it crosses the x-axis. So then we'll go to our second trace 5 in our calculator because we want to know the intersection. So go into our calculator. My y equals cleared out. I have negative 16x squared minus 8x plus 120. I have my y2 is 0. I want to go to zoom. And again, 6 will go to a standard window, but I know this is at 120, so it's going to take more than the standard window. So I'll go to zoom fit so that I can at least see the graph itself. So here's where the rock is starting, and we want to know how long it takes for it to hit here. So we do second trace 5. So this is where our rock is. Our rock is actually starting up at the 120, so this is actually where rock is. I want to point this out. You see where it says 3e negative 9? What that really means is you have negative 9 spaces back to the left. This is scientific notation. You move your decimal left 9 spaces. That would be 0.0000000, and it gets to 3, so that really rounds to 0. That's at 0, 120. So here's the rock being thrown. I'm following the path of the rock, and then it's going to hit the ground. So I do enter, enter, enter. I get 2.5, 0. So x is equal to 2.5. So our question is asking, how long does it take the rock to reach the ground? So it takes the rock 2.5 seconds to reach the ground. The biggest aspect of these word problems is understanding what is the question actually asking you for, and does your answer make sense? Always go back to that. A rock is being thrown and it takes 2.5 seconds for it to hit the ground. If you throw something, it doesn't take long for it to reach the ground. So this makes sense. And it's up 120 feet up in the air, and you throw it up, and then it will come back down. So this actually does make a lot of sense. These were a lot of when it hits the ground, but again, you can also see ones that have maximum. If it asks what is the maximum height, you're looking for the y value. If it asks when does it hit the maximum height, when is your time, you'd be still finding your maximum, but you'd find your x value because that's time. Now, if it asks you, when does it hit a height of 10 feet? You would still be given your height. So on here, let's say, when does the rock hit a height of 10 feet? If I go back to this problem, we have this equation. And if the question said, how long does it take for the rock to hit 10 feet in the air? So really, instead of it hitting the ground, we actually say it wants to hit a height of 10 feet. So in my y2, I would just put 10 feet and find the intersection. So really, it's just asking what is the question asking, and then what values do you have? Word problems are all about understanding the question.